In problem 25.31, there is a copper transmission cable. It's 100 kilometers long. You can see that right there. And you can see it's 10 centimeters in diameter, not radius. I just want to point that out. Okay. And we got a current of 125 amps. Then we know the potential drop across each cable, so the voltage, what they want to know. And they want the electric energy that is used every hour. Okay, so that's what we're looking for. Okay. And first, so we're going to use Ohm's law to figure that out, to find the potential. So it's going to be voltage is going to equal current times resistance. But we also know that the resistance is of a cable, and we know a bunch of things about it. Okay, so we're going to have to use the equation for resistance that involves resistivity. So we're going to use I rho L, the length, divided by the cross-sectional area of the cable. And it looks like, because it has diameter, it must be a round cable. So it's going to be I rho L over pi r squared. Okay. So now we can start to plug stuff into that. So it's going to be the 125 amps times the resistivity, which I looked up as 1.68 times 10 to the negative 8 ohm meters. Okay. Times the length. It tells us 100 kilometers. We're going to convert that to meters, so it's 100,000 meters. Divide that by pi. And the 10 centimeters, we're going to have to take that, just convert it to meters, so it's 0.1 meter. And half of that for the radius is 0.05 meters, quantity squared. Okay. We multiply all that stuff together, divide it all out, and we get 26.7 volts. In the second part of the problem, they ask us what's the energy dissipated as thermal energy every hour. Well, okay, so we're going to start with the energy. Just like any time we talk about energy, okay, it's the integral of the power with respect to time. And we know for electric energy, power is going to be VI dt. Okay. The current remains constant and the voltage remains constant. There's nothing that's going to change those. So it's just going to be VI maybe times time. So we can just multiply those values together. So we're going to take the 26.7 volts that we got from the first one. We're going to take that times the 125 amps that were given. And we're going to take it times the base unit, which is going to be seconds. 1 hour is 3,600 seconds. I multiply all that stuff together and I get about 12 million. Volt times amps is joules per second or watts, and times seconds would give me just joules for my answer, maybe. So 12 million joules will do it.